Hi everyone, welcome to the video on the antiderivative of ax plus b all to the power of r. I'm going to be having a look at two different situations here and how we can differentiate these when r is not equal to -1 and when r is equal to -1 as well, because they are two very different situations. The way I'm going to do this is, first I'm going to show us what would happen if we were to do the derivative of this thing, so that when we anti-differentiate we can do the opposite. So you might remember a function like this needs to be differentiated using the chain rule. And the way that we would differentiate this is, well, we'd take the power down the front, so it would be r times ax plus b to the power of r minus 1, so we've minus 1 from the power, and then we need to multiply by the derivative of the inner function, which is just a. And so that would give ar times ax plus b to the power of r minus 1. Now that's the derivative. Okay, that's not what we're doing in this topic, but that was just to show what we would do so we can do the opposite of that. So to do the opposite of that, what I'm going to do is I'm going to, well, instead of multiplying by the old power, I'm going to divide by the new power. So I'm going to write this ax plus b to the power of r, and I'm going to divide by the new power. Now the new power, I have to add 1 onto that, so it's r plus 1. I'm going to divide by that r plus 1. Okay. Also, instead of multiplying by the derivative of the inner function, I'm going to divide by that derivative. So I'm going to put that a down the bottom here as well. And that is the rule for the antiderivative of this function. So again, it doesn't work if r in this case is -1, and we have a special rule for dealing with that. So let's just see how it works in a couple of questions. Find the general antiderivative of these. So first things first, I'm going to write the antiderivative of 2x plus 3 all to the power of 5 dx is equal to, now it's going to be 2x plus 3 all to the power of 6, because I've added 1 on. I need to divide by the new power, which is 6, and I also need to divide by the derivative of that inner function, which is just 2. So that in the end gives 2x plus 3 to the power of 6 all over 12. You might choose to write that as 1/12 at the front of 2x plus 3 all to the power of 6. That's just another way of writing it, and that's totally acceptable as well. And if we do the second one here, the antiderivative of 3x minus 1 to the power of -2 with respect to x is equal to, so I've got 3x minus 1 to the power of -1 now. I need to divide by that power, which is -1. I also need to divide by the derivative of the inner function there, which is 3. And in the end that gives 3x minus 1 to the power of -1 all over -3. You might choose to rewrite that in a nicer format, so positive divided by negative makes it negative, and we can move this here down the bottom to give it a positive power. So it can actually just be written as 1 over 3 times 3x minus 1 all to the power of 1, which I don't need to write there. And I've been a little bit slack with these because what I have forgotten to do is I've forgotten to actually write plus c on them. So I should make sure to do that because these are indefinite integrals. Okay, so it's really important to have that, and that's a check, just like I've done now, that you should be doing as you go through these questions. I should also make sure to do that up here, but there we are, all fixed. Anyway, I will leave that video there, and we'll have a look in the next video at the situation when r is equal to -1, and we'll see how that's done differently. See you then.